The question says that use Lenz law to determine the direction of induced current in situations described in figure 6.16. A wire of irregular shape turning into a circular shape. This figure describes a wire that is of irregular shape and it is turning back into a circular shape. And the second question is a circular loop being deformed into a narrow straight wire. So earlier it was a circular loop, now it has been transformed into a straight wire. So we have to find out what would be the direction of induced current in both the cases. In the first case, the magnetic field lines are going into the plane, and in the second case it is coming out of the plane. Now we will be using Faraday's law and Lenz law in order to understand and find out what would be the direction of current in this cases. The Faraday's law says that the EMF, induced EMF, due to which the current would flow, would be equal to minus of d phi by dt, where d phi is the change in flux and where flux is the dot product of magnetic field and the area vector. And Lenz law says that the direction of induced current will oppose the change in flux that created it. So we will have to focus on the flux and how it is changing, and the flux will be opposed, the change in flux will be opposed. That's how the current will be produced. So in the first case, we see that irregular shaped wire, when it turns out to be a circular shape, then the area will increase, or as flux was defined as B dot A. So since area will increase, d phi or phi will increase. So the induced current will oppose the increase in phi or the flux, or opposite magnetic field will be created. So initially the magnetic field was going into the plane, so magnetic field out of the plane will be created, and thus in order to create magnetic field out of the plane, that is coming out of the plane, the current has to flow in anti-clockwise direction, that is A, D, C and B. So by applying right hand thumb rule, we can say that if the current flows in anti-clockwise direction, then the magnetic field will be coming outward, the current will be induced. In the second case, it says that the area is decreased or flux is decreasing, d phi is decreasing. So the induced current will support the flux to restrict it from decreasing, and thus the magnetic field will be in the same direction as before, or the magnetic field will continue to be out of the plane, and thus we will say that in order to have magnetic field out of the plane just like before, the anti-clockwise direction current should flow, or A dash, D dash, C dash, B dash should be the direction of current. Thank you.